दोस्तों आप हमारे कोर्स के जो ये फीचर है आप देख सकते हैं, कुछ ऐसा कंटेंट रहेगा लास्ट में। दोस्तों आप कुछ कोर्स में लास्ट में कुछ ऐसा कर सकेंगे जो आप जावा प्रोग्रामिंग जावा स्क्रिप्ट सीखकर, जो हम इस वीडियो में आपको जावा स्क्रिप्ट है वो सारी स्क्रिप्ट सिखाएंगे, जावा स्क्रिप्ट, एंड आप प्रोग्रामिंग करके जो कोडिंग करके ये ऐसा कुछ बना सकते हैं। लास्ट में आपको सारा प्रोजेक्ट गाइड करेंगे दोस्तों, कुछ ऐसा आप बना सकेंगे लास्ट में, वो स्क्रैच से स्क्रैच चलाता सिखाएंगे हम आपको। जो कंटेंट है आप सही में भी हमारे वीडियो को एंजॉय करेंगे। ये कुछ ऐसा सारे एनिमेशन जो है PHP फाइल की वो सारी एनिमेशन बताएंगे आपको। वीडियो गेम्स एंड बहुत सारे एनिमेशन।
My name is Ravi Perlena, and today you're going to learn how to program. No previous experience necessary. Now, being a programmer is about learning to speak to a computer, but it's also about learning to see possibilities. In this guided project, you'll learn the basics of programming, but you'll also learn one of the most important skills a programmer needs to have: how to turn small ideas into ideas that scale. Because when you write even a few lines of code, you're creating a seed. Your computer then transforms your code into creations larger than anything you might have ever thought you could make. In this guided project, you're going to learn to think like a programmer by solving a crime. The crime is a fictional one, but the skills you'll learn are fundamental to being a programmer. They'll enable you to spot connections between the power of programming and real-world opportunities. As an example, a few years ago, my sister came to me with a problem she was having, helping her children stay focused. I programmed an app to help, then watched as it was shared with more and more of our friends. Today, that app has been downloaded by millions of users and resulted in my being offered hundreds of thousands of dollars worth of contracts with global corporations. Families around the world have sent me emails telling me how the app was able to help them, even more than it did with my sister. Or, as another example, one day, I was trying to learn a foreign language, and I programmed a simple system to help myself. Later, I found my program was being featured on the front page of the BBC World Service and syndicated on numerous news sites around the planet. These are just two examples that show how a programmer can take something that starts off small and turn it into something that reaches people. You're in the right place to get started. Now, whether your end goal is to become a professional programmer, to start your own company, to learn to program with your kids, or just to be part of the conversations about the scale of possibilities that come when you can think like a programmer, this project will give you a firm start. And after our time here, you can continue to build your skills in subsequent guided projects. Now, the activities in this project were carefully chosen after reviewing 40 years of extensive research into the best ways to introduce computer programming skills. In fact, computer science is one of the highest dropout rates of any subject. This is because most beginner programmers get stuck when they try to learn both how to think like a programmer and code all at once. We'll start by coding with puzzle blocks in a series of exercises designed to getting you thinking like a programmer. Next, you'll learn how to take these puzzle blocks and transform them into actual code. This approach has been scientifically proven to save beginners endless frustration and confusion. We'll then take advantage of some of the new possibilities for learning granted to us by the modern cloud-based environment offered in this platform. Finally, you'll take the skills you learn and apply them in a detective mystery challenge, where you'll sort through thousands of lines of data to find a thief. Click the button to continue on to the next section, and we'll launch into our cloud-based environment and get started.
Welcome to the Rhyme environment. On the left side of the screen, you'll see a large grid of gray squares with a green paintbrush in the top left corner. For our initial few exercises, we'll instruct the computer to draw a series of shapes within the grid. Before we start, you may want to take a moment to orient yourself with the video controls in this environment. to follow along. Others like to follow along from the start. Either approach is fine. See what works best for you, but if you find yourself getting overwhelmed, try just watching first and then coming back to it yourself after. We'll first explore some underlying concepts of programming in a visual manner by using puzzle bricks. In subsequent videos, we'll take off the training wheels and review the same concepts we're learning in this video, but we'll replace the puzzle bricks with a professional programming environment. We'll snap together different bricks to create programs that direct the computer to draw different shapes. To get started, let's click on the menu labeled Move. Then drag a block labeled Move Right into the area to the right. When you click the Run button, you'll see that the pen now moves from its starting square to the square 1 to the right of it. Let's try sequencing some commands together. From the Move menu on the left, drag 2 additional Move Right blocks and 2 Move Down blocks to the area to the right. Notice how the puzzle bricks are shaped. Go ahead and snap the blocks so that they connect. From the Move menu on the left, drag 2 additional Move Right blocks and 2 Move Down blocks to the area to the right. Notice how the puzzle bricks are shaped such that they can be connected together. Go ahead and snap the blocks so that they connect together in an alternating sequence of Move Right, Move Down, Move Right, Move Down, and Move Right. If you hit the Run button again, you'll see that this time, the pen draws a small staircase. It will draw it block by block and highlight the current command as it goes. This time, go ahead and fully reload the page. Next, we're going to try to make the first 6 squares green. Since the first block is already colored, we'll need to call the Move Right command 5 times to accomplish this. Now, we could do it simply by chaining 5 Move Right blocks together, but what would happen if in our next program, instead of only 5 block by block, and highlight the current Move Down and Move See that this time, the pen draws a small staircase. It will draw it block by block and highlight the current command as it goes. This time, go ahead and fully reload the page. Next, we're going to try to make the first 6 squares green. Since the first block is already colored, we'll need to call the Move Right command 5 times to accomplish this. Now, we could do it simply by chaining 5 Move Right blocks together, but what would happen if in our next program, instead of only 5 blocks, we want Instead of only 5 blocks, we wanted to move 10,000 blocks. Let's learn a better way of doing this, one where it's totally effortless, regardless of whether we're moving right 2 times, 5 times, or 10,000 times. Instead, we're going to use a loop block from within the Loop menu. We'll use this block to repeat everything inside of it a set number of times. For some people, it might help you to think about when you find a couple songs you really like, and you want to listen to them over and over again. You can accomplish this by just dragging the songs into your playlist multiple times. Or, you can drag them just once, then hit the repeat icon on your music player. This is one of the most fundamental concepts of programming, where we always try to use loops whenever we want to repeat commands, instead of duplicating our typing multiple times. Zero, and keep repeating until count reaches 4. Each time the loop completes everything inside it, we'll have it increase count by 1. To do this, grab 3 number blocks out of the Numbers menu and place them inside the empty slots on the loop block. Enter the numbers 0, 4, and 1 inside the loop block. Finally, place a move right command inside the loop block. If you hit the run button now, you'll see that the pen moves 5 times and ends on the 6th block. Remember, since our counting starts at 0, the 6th block is labeled with the number 5. I know starting your counting from the number 0 instead of 1 can be confusing at first, but with a little practice, it'll become natural. Now, perhaps what we just did with the loop block already seems logical and straightforward to you. That's fantastic if it does. But for most beginner programmers at this point, it won't be. Since loops are one of the most foundational concepts in computer programming, a poor understanding of them early on will cause all sorts of headache later, so it's important that we're certain we really understand what's going on here. This may seem a little silly, but if you can put the silliness aside, we're going to think about a little story that's been proven with lots of careful research to help beginner programmers build the right mental understanding from the start, so that when we put this into actual code in the next videos, you'll know exactly what's going on underneath. Let's pretend. I'm going to erase the whiteboard and rewrite different numbers on it throughout the course of our program. The contents of the whiteboard will vary, so we might also refer to his whiteboard as a variable at times. Again, since the contents of his whiteboard will vary and change over time, we need to give the whiteboard a name so we can talk to him about the actual whiteboard itself, rather than the content that's currently written on it. In our previous command, we told him to name his whiteboard Count. This allows us to ask him questions like, "Hey 4, what's currently written on Count?" And he can look at his whiteboard that we named Count and respond, 0. Or, if 5 was written on there, he could tell us, now Count has 5 written on it. Or he could tell us true. Or he could tell us pizza. Or he could tell us anything. Anything that he wants to write on his whiteboard, he can write it, and then we can always ask him, "Hey, what's currently written on that variable we named Count?" And he'll tell us whatever is written on there at that time. But to start, we've instructed him to begin by writing the number 0. Second, he'll check what's written on his whiteboard against the orders he's been given. If what's written on his whiteboard satisfies the orders he's been given, he'll call it a job well done and quit for the day. Otherwise, he'll move on to his next step, where he yells out a list of commands for other robots to follow. After, and only after he's finished every single command on his list, will he then loop and rewrite the other robots' whiteboard Count. We told our loop robot to start by at what happens with each set of commands to his other robots. He'll keep repeating this, looping through the same process each time until what's written on his whiteboard fulfills his job requirements. Then he'll call it a job well done, also known as a variable. We decided to name this whiteboard Count. We told our loop robot to start by writing the number 0 on the whiteboard. Then we told him, each time he gives all the commands inside of the loop block, to increase the number on the whiteboard by 1. The only command we placed inside the loop block was a move right command. So, the first time he finishes giving this command, we notice the paintbrush on the grid moves right by 1. He then erases the 0 from the whiteboard and then writes a 1. He then yells out the move right command again, and the paintbrush moves another square, and the whiteboard gets updated again. This continues until the number on the whiteboard exceeds the second number we gave him. He then stops. In our case, the paintbrush stops on the 6th column in the grid. for a series of different conditions. To do this, we're going to use a second type of control structure, called an if-else block. We could think about this block as a second kind of robot we'll name Iffy. She's a sort of traffic director robot. We'll give her a comparison structure, like this one, that says, check if count is less than 2. We'll then give her instructions about what to do if the comparison sequence is true, or else if it's false. For example, we could say, if count is less than 2, move up, or else, move down. In this case, each time she's called, she'll check what 4 currently has written on his whiteboard. If it's less than 2, she'll direct a move up command, or else, she'll direct a move down command. Let's try an example of this together as we try to make this drawing. Go ahead and take an if block out of the if menu. Place it inside the loop block, then place the move right command inside of the if block. The if block attaches to 2 other puzzle pieces. The first is going to be a comparison sequence block we can find in the comparison menu, and place it in the slot to the right of the if block. The second is a set of actions to take if the comparison is true. In this case, we already directed it to call the move right command. For our comparison block, we want to examine the count variable that our loop is using to see if it's less than 2. To do this, take a brick for the count variable out of the variables menu and put it in the first part of the comparison block. Use the drop-down arrow on the comparison block's equal sign to change it to a less than sign. Let's try an example of this together as we try to make this drawing. Go ahead and take an if block out of the if menu. Place it inside the loop block, then place the move right command inside of the if block. The if block attaches to 2 other puzzle pieces. The first is going to be a comparison sequence block we can find in the comparison menu, and place it in the slot to the right of the if block. The second is a set of actions to take if the comparison is true. In this case, we already directed it to call the move right command. For our comparison block, we want to examine the count variable that our loop is using to see if it's less than 2. To do this, take a brick for the count variable out of the variables menu and put it in the first part of the comparison block. Use the drop-down arrow on the comparison block's equal sign to change it to a less than sign. Then, grab a number block from the numbers menu and place it in the second slot of the comparison block. Enter the number 2. Now let's expand our if block to check for a second condition. Click the gear icon on the if block to expand it with another else if check. We'll do a similar process like we did with the first if statement to instruct the computer on the comparison block's equal sign to change it to a less than is going to be a comparison sequence equal sign to change it to a less than sign. Then, grab a number block from the numbers menu and place it in the second slot of the comparison block. Enter the number 2. Now let's expand our if block to check for a second condition. Click the gear icon on the if block to expand it with another else if check. We'll do a similar process like we did with the first if statement to instruct the computer that if the count is less than 4, it should move down. Again, we'll drag a number comparison out of the comparison menu. We'll drag a block for the count variable out of the variables menu and place it in the first slot. We'll change the equal sign to a less than sign, and we'll drag a number block out of the numbers menu, place it in the second slot, and set the number to 4. Within this block, we'll place a move down command. Finally, let's expand our if block one last time to add an else condition. This one doesn't require a comparison block, it just does everything we place inside of it if the previous else checks fail. Let's tell it to both move down and move left if the first 2 conditions are false. Let's take a moment to review the instructions we provided the computer to get this shape. The first thing to notice is that we're only providing 3 commands that directly move the paintbrush. Move right, and move left if the first two conditions are false. Within this block, we'll place a move down command out of the variables menu and place it in the first slot. We'll change the equal sign to a less than sign, and we'll drag a number block out of the numbers menu, place it in the second slot, and set the number to 4. Within this block, we'll place a move down command. Finally, let's expand our if block one last time to add an else condition. This one doesn't require a comparison block, it just does everything we place inside of it if the previous else checks fail. Let's tell it to both move down and move left if the first two conditions are false. Block inside the loop, but outside of the if block. Pause the video here and see if you can predict what will happen. Then, run it and see. We're now going to cover our final big concept before we shed the training wheels and switch over to programming actual using much bigger numbers where that won't be possible. So let's try doing it with only one move right command and one move down command by using two loops. For the first loop, this time we'll call its variable outer count. And tell it to go from 0 to 3 by 1. Within this loop, we'll place our single move right command and a second loop. For the second loop, we'll name its variable inner count and tell it to go from 0 to 1 by 1. Within this block, we'll place Now, when you hit the Run button, you should see this. Notice how each of the numbers we placed in the slots on the loop are used to direct the whiteboards added to the right of my video. Those whiteboards then direct how the loops operate. Based on them, the loops then call either the move right command or the move down command, which in turn controls the movement of the pen. Okay, now let's see if you can put together everything you've learned about how loops work to make this drawing. Now, there's lots more that could be learned by exploring the different ways to instruct a computer to paint squares. If you'd like, you could head over to the discussion forums where I'll post some pictures of challenge shapes to draw, along with answers of how to create them. You could also imagine your own shape. First learn just the underlying. Really enjoying this approach of using puzzle bricks to help you first learn just the underlying concepts of programming. There's a free program called Scratch, which focuses on letting you do just that. It'll take you way beyond just painting squares, into creating advanced video games, entirely by snapping together puzzle bricks. There's lots of different resources out there for learning to use Scratch. Full row of blocks. Let's remember our process for doing this. First, our robot took out his whiteboard and wrote down a variable called count. He initially wrote this down as 0. To do this step in our code, we'll write the command let count equal 0, semicolon. Next, he compared what was written on the whiteboard to his job requirements. Let's set his requirements here by telling him, while count is less than 19, keep doing everything between these curly braces. It's not necessary for the program, but for organization and making things easy for others to read our code, we'll indent everything inside the curly braces. Inside the curly braces, we'll tell him to move right. Next, we'll have to update the contents of his whiteboard to write count as one higher than the previous number it was. It's extremely important we remember this step, or else our robot will just keep trying to move right and never actually complete his job requirements, and will cause your computer to freeze up. Once you have these 4 lines written in, save your file and try reloading your browser. It should paint the first row of your grid. Now, because creating loops like this is such a braces, we'll tell him to move right. Next, we'll have to update the contents of his whiteboard to write count as one higher than the previous number it was. It's extremely important we remember this step, or else our robot will just keep trying to move right and never actually complete his job requirements, and will cause your computer to freeze up. Once you have these 4 lines written in, save your file and try reloading your browser. It should paint the first row of your grid. Now, because creating loops like this is such a frequently used process in computer programming, there are a number of shorthand abbreviations for making typing this more concise. The first is that we can simplify the line that says count equals count plus 1 by simply writing count with 2 pluses after it. This is the exact same thing, just easier to type. The next is we can actually collapse all of the control lines into a single line by replacing the word while with the word for and using semicolons to separate each component. I find it helpful to have a sentence to say in my mind each time I write something like this. Personally, I use the sentence, starting with count at 0, for as long as count is less than 19, increase count by 1 each time. We now have our paintbrush moving using a for loop. If you save this file and then reload your browser, it should look like this. Like before, let's look at how we can place an if condition for the move down command. We'll only move the paintbrush down a row if the count is greater than 10. Next, we're going to repeat the steps we did in the first video of creating a staircase using an inner loop and an outer loop. We'll have the outer loop move right and the inner loop, which repeats itself twice each time the outer loop runs, move down. First, we'll create an outer loop. In this case, we'll instruct it to begin by writing 1 on its whiteboard and keep going as long as the number on that whiteboard is less than 6. In other words, while it's a 1, a 2, a 3, a 4, or a 5. Each time it does this, it's going to call a move right command, as well as fully running a new inner loop. We'll create an inner loop that moves twice for each time the outer loop moves once, by telling it to start at 0, to keep going as long as inner count is less than 2, and to increase its count by 1 each time. So the inner loop will run while the inner count is 0 and while inner count is 1. Once it reaches 2, it stops. As you can see, this creates our staircase effect. Now, like we did in the first video, we'll update the inner loop to use the outer loop counter when checking if its work is complete or not. Now let's try a new command we haven't done before. What if we wanted to have the paintbrush jump to a completely new position instead of drawing lines? The first step is to identify for the computer the specific squares we want to work with. As you can see on the grid, Each square is labeled with a set of numbers, the first for the row and the second for the column. If we want to jump to the 6th column of the first row, we can do this with the following syntax, which helps us select that square. Next, we just need to call the paint command on that specific square. Besides accessing squares directly via numbers, we can also create variables that represent those numbers. This has the exact same effect. We can also separate out the row from the column. Again, we can achieve the same effect as before by first creating a variable that represents the first row of the grid. You don't need to type this in, but pause the video and see if you can think about how you would update this if instead of the first row, you wanted to use the second row, and if instead of the 6th column, you wanted to paint the square in the 3rd column of the second row. Remember, the computer will begin its counting at 0. The first step is technically optional, but it makes our code a lot easier to manage. That's going to be renaming the variable from first row to second row. Keep in mind, that only changes the name we use to refer to the whiteboard, not the actual contents of what's written on it. The contents is always what's on the right-hand side of the equal sign. So we'll need to update it from being the first row of the grid, or as the computer sees it, the 0 line, to the second line, or as the computer sees it, the 1 line. Finally, we'll need to update the column number from the 6th column to the 3rd column by writing a 2. Now let's use this technique to paint our full first row. This way of writing it is useful, because if we didn't know that the row had 20 squares in it, and simply wanted to instruct the computer to paint the full row, we can use the array's length variable of the first row to do so. It would also allow us to do things like this if we wanted to paint the first row in a checkerboard style. We'll explain exactly how this command works in future lessons, but for now, we can just say it differentiates even from odd numbers. By accessing individual grid squares, you've actually been learning the fundamentals for working with structured data. In the next video, we'll go deeper into this, showing how to create your own data structures from scratch and manipulate them in order to solve a problem. Welcome back. So far, we've only been giving commands to move a paintbrush, but we'll now focus on how to manipulate data in order to answer questions. The first question we'll ask is, who stole the cookie from the cookie jar? Now, this may seem like a silly question, but it's a first step, and it's the same foundation for other skills you'll learn later. Questions like, who is the best target audience for my product? Or, if you want to answer questions like, is the cell in this X-ray a healthy cell or a cancer cell? The first step is answering questions like, is this an innocent suspect or a cookie thief? So, let's examine our cookie case. We've rounded up each of the usual suspects, pig, cat, dog, lizard, duck, mouse, and recorded all their information for you. But it'll be up to you to determine which is the real culprit and who just happened to be at the wrong place at the wrong time. We can access the recorded information from a table you'll find on the desktop of your RHYME environment in the cookie folder under the file name cookie_data. In it, you'll find one column for the names of each suspect, one for their height in centimeters, one for their eye color, and if they're a smoker or not. Let's start by writing the size entries into the file cookie.js inside Visual Studio Code, the same way that we can group together entries in a spreadsheet by putting them together in a column. In JavaScript, we group together items by separating them with commas and then placing them inside brackets. This collection of entries is called an array. We'll then assign this array to a variable called sizes. One way to think about an array would be to think about drawing grid separator lines on a whiteboard, so that you can then draw multiple items on the whiteboard, even though there's only one whiteboard. Notice the difference between these three whiteboards. One is totally blank. One has grid lines that creates multiple cells, but each of the cells are blank. And one has both grid lines on them and content in each of the cells. When programming, this would be analogous to having an undefined variable, an empty array variable, and a populated array variable. If you were to load this project in your web browser, at this point, you'd get a blank screen with nothing on it. This is expected because all we've done so far in this program is to define some data. We haven't actually made any commands or outputted anything. But it would be nice to be able to peek under the hood of the program and make sure that it's operating as we expect it to. And we're not going to run into a mess down the line when the program becomes more complex just because we've already done something wrong. Let's send some information to the developer console so that we can make sure everything is running okay. We'll do this with the console log function. Type console.log and inside of your parentheses, type the word sizes. This tells the developer console that you want to send something to its log. Inside the parentheses, you tell it what you want to send. So we send it the contents of our sizes array. Now, when you run this, you'll see an entry in the console letting you inspect the content of the sizes array and make sure it appears as you intended and know that your program is actually doing something even if nothing is yet changing on your screen. So we've confirmed that the system is correctly storing our information about sizes, but there was more information in that table than just sizes. Each row in the table represents another kind of grouping, a different kind than we have in the columns. In the columns, there's a header describing the category of information, whereas the rows are more about the row number. When you combine the two of them, you have a cell that provides the actual value in that entry. So, for example, we might tell the computer, using the key size in the row number 0, tell me what the value is, and the computer will tell you 100. Or, if you ask the computer, using the key size in what I would call row number 3, but you, the computer, would call row number 2, tell me the value, and it will tell you 80. And if you ask the computer, using the key eyes in your row number 2, it will tell you blue as the value. So let's update our JavaScript code to fully account for all the information in our spreadsheet. To prepare, let's separate out our array to have each entry that represents a row be written on its own line. Remember, the lines and spacing don't impact the functionality of the program, but they will help for our own organization and readability. We'll begin by placing curly braces around each entry of our dataset. This instructs JavaScript that the entry row is going to be a group of key value pairings. In JavaScript, this is referred to as an object. Let's start by entering the size key to each line of the array, since we've already got that partially entered in. Before the value, we're going to type the word size and a colon in order to set the key. If you look at the console log again, you'll see that each entry row now has a key of the word size and a corresponding value. We're next going to create entries for the name, the eye colors, and if they smoke or not, each separated by a comma. Notice that the order we enter these in is irrelevant. Also notice that the names and the eye colors are represented by words, so we place quotation marks around them. But the size is a number, so it does not get quotation marks. Smokes is simply true or false, yes, no, 0, 1, a binary answer. Refer to this kind of value as a boolean. Since our variable now has more than just sizes in it, let's rename it from sizes to usual suspects. Again, we'll use a lowercase u and an uppercase s. Also update the console log to use the new variable name. To make this more visually interesting, I've configured your program to automatically generate a website displaying the usual suspects variable. But you could access the exact same information from the console log statement you created. If you scroll down to the bottom of the website now, you'll notice a clue I added to help us identify the cookie culprit. In the next video, we'll take this clue and others we receive and use them to nab our suspect. Welcome back. In the last video, we created a data structure that contained entries for all the suspects in our case. In this video, we're going to filter that information down until we have just one suspect remaining. Before getting to this, let's first imagine we were going to a store to purchase stuffed animals. We decided that we wanted to purchase all the stuffed animals in the store, which were larger than 40 centimeters. To do this, let's imagine that there are 3 key items in the store. The first is a locked display cabinet, which contains all of the stuffed animals that the store sells inside of it. The second is a podium which holds one stuffed animal at a time. And the third is a shopping cart, in which you'll place any items that you wish to buy. Your goal is to buy any stuffed animal that's more than 40 centimeters tall, but to leave behind any of the smaller stuffed animals. At the beginning, the display case has 6 items in it, the podium has 0, and the shopping cart has 0. You walk into the store, and a sales assistant greets you. He tells you that his name is 4. You tell him that you need to measure each of the stuffed animals to determine if you wish to buy it or not. So, one by one, 4 brings out each of the items in his inventory and places one on the podium. The item is then measured, and, based on that, you tell him if you would like one of that model of stuffed animal or not. If you do, he'll place one of that type of stuffed animal in your shopping cart. If not, he'll simply move on to the next item in his inventory, placing them one at a time on the podium for you to do your measurements. At the end of the experience, you leave with only what was placed in your shopping cart. That is, only the items you wanted that were taller than 40 centimeters. Everything that was in the display cabinet and the podium, you leave behind when you leave the store. Now let's get back to thinking about our case. Here again, we're going to have 3 key variables we'll be doing our work with. One, called usual suspects, plural, which contains a list of all the possible suspects in our case. One, name usual suspect, singular, which refers to one specific suspect that we'll be examining, and suspects, which is a list of all the suspects that we still think are active suspects after we've examined them. This is a common naming convention, where when there's both a singular and plural form of the word, where there's variables within a loop, The singular is used to refer to just one entry used within a particular round of a loop. Now let's get back to our code. Here, we're going to make another variable named suspects that we can use to filter down just the suspects that match the clues we receive. We'll fill it in with entries in just a bit, but for now, let's just make an array with nothing inside of it. Again, we can think of this as drawing the grid separators on a whiteboard, but not yet drawing anything in the cells. For our next step, we're going to loop through each of the suspects within the usual suspects array we just made and decide if they're still an active suspect in our case or if we can discard them. Now, don't type this next part in just yet. Let's think about it first. With everything we've learned before, we could decide to do this by using a classic for loop with a count variable, and then using the count variable to pull out a specific suspect from the usual suspects and assign it to a variable called usual suspect singular. This would work, and it gives us the most flexibility when working within our loop. But since this is such a common process, JavaScript gives us many different ways to accomplish this. Let's learn one of the simpler options available to us. Go ahead and type in for, open parentheses, let usual suspect singular of usual suspects plural, end parentheses, curly braces. This is shorthand for the same process. Inside these curly braces, we can access the variable usual suspect singular to represent the particular entry of the current usual suspects plural in the loop iteration. Inside our loop, we'll place our first if condition by checking if the size of a particular usual suspect is greater than 40. If it is, we'll add it to our suspects array by sending it to the array's push function. If it's equal to or smaller than 40, we can ignore the entry, and it never gets added to the suspects array. After we save it, if we then return to our website, we can see the suspects that still remain on our suspects whiteboard along with our next clue. Before we move on, let's do a quick review of what's going on in our program so far. Our program begins with two whiteboards, one named usual suspects and one named suspects. The usual suspects whiteboard is designated as a particular kind of whiteboard that's able to have multiple entries written on it. To start, it has 6 objects written on it. The suspects whiteboard is also designated as a kind of whiteboard that's able to have multiple entries written on it. But to start, it doesn't yet have any entries written on it. We then have a for loop, which goes through each of the entries one at a time. Each time he repeats, he pulls out just the current entry from the usual suspects plural whiteboard, writes it onto another whiteboard named usual suspects singular. Each time for makes a new round of the loop. If he then looks and pulls out the size property of that specific suspect, if it's greater than 40, she adds it into the list of suspects on the suspects whiteboard. In programmer speak, she pushes it into the suspects array. They continue this until all of the usual suspects have been looped through and they've either been copied onto the suspects whiteboard or they've been dismissed. Now, within our first if statement, we'll place additional if checks to test if the suspect has 3 letters in their names. We'll do this by using 3 equal signs in a row. When we use just a single equal sign, it sets the value. If we accidentally used it here, we would be telling the program to set the length of the name to be 3. This is a common beginner mistake and leads to all sorts of problems that are difficult to resolve. Instead, whenever we want to compare if a value is equal to another, we'll use 3 equal signs in a row. If we reload our webpage now, we knock off another suspect and get another clue. Once again, we'll make another if check. Remember that since this time we're looking at a word, we need to use quotation marks. Also remember that all words are cap sensitive. If we save and reload our browser now, we'll be down to our final 2 suspects and our final clue. Now we can add our last check, then finally put our nefarious cookie thief behind bars. Congratulations, you've nabbed the cookie pilferer. And, more importantly, you've done some pretty complicated data manipulations to solve this case. You can give yourself a quick pat on the back for this one, but the real test is going to come in the next video, where we've got a special challenge waiting for you. And you're going to need to solve it yourself, without a video to copy. If you'd like, you can take a moment here to review everything you just did, and make some notes for yourself. In the next video, you're going to need to really apply everything that you just learned. This is it. You've now reached the final challenge, where you're going to have to put together everything you've learned and earn your badge as a detective programmer. Once again, another cookie has gone missing from the jar, but this time, Pig is behind bars, and all of the other usual suspects have alibied out. That means it could be anyone in your entire town of 5,000 people. If you open up the directory cookie2 and the files within it, you'll get a list of all the citizens in the town, along with 4 clues. Now, you may notice that the clues on your screen look different from the ones in this video. That's because you're going to need to solve this one for yourself. Like in real life, there's many other people on the internet trying to solve similar problems to the one you're encountering, and you're most welcome to learn from their experiences by reading about them in the course discussion forums. But just because their answer may have been that citizen number 230 was the cookie culprit, that doesn't mean that answer is going to work for you. Your answer will probably be different. Instead, you'll need to learn about the process that they use and adapt it to your own set of clues. And if when you're done, you decide to post your answer for others, don't worry about giving away the answer or spoiling the exercise for them. Go ahead and help them as much as you'd like. They also need to apply your techniques for themselves. In the JavaScript file, you can access all the town citizen information in the same array and key value pattern that you learned about in the previous videos. I've created the citizens array for you, which has all the data from all 5,000 citizens already entered into it. I've also already entered a loop that goes through each citizen of the town and places them into the suspects array. The website then displays the full contents of the suspects array. But it'll be your job to keep placing conditional checks inside the loop so that instead, it only displays the relevant suspects. Ultimately, you'll need to keep going with that process until it only places one single suspect inside the suspects array. If you get stuck, be sure to check the console in the developer tools panel for additional information. If you're still stuck, post a screenshot to the course discussion forums for more help. Be sure your post includes screenshots of what clues you received, what code you entered in, and what happened when you tried to run your program. Remember, your clues will be different than others, so they'll need that information to be able to help you. If you successfully narrow down your suspects to just a single suspect, keep a note of the citizen ID of the culprit. Then, go ahead and close this video and proceed to the assessment portion of this course. Enter the citizen ID in there. If successful, you'll have conclusively proven your abilities as a certified cookie thief detective programmer. And for any super overachievers taking this course, I've also included a second hidden challenge that's purely optional. Simply finding the cookie culprit is more than enough to prove your knowledge as a cookie detective. But you could also try and find who hired the cookie thief. Who's the one really pulling the strings? Now, we're not exactly sure how the police department came about this clue, but we do know that it's accurate. We know that the client of the cookie thief is the person in the town who has the median bank balance. That means that if you were to line up all of the people in the town based on their bank balance from lowest to highest, it would be the person in the middle of the line. If the town only had 11 people in it, it would be this person. Now, people write all sorts of academic papers on what the most efficient way to solve a problem like this is. Don't worry about being efficient. If you can just find any solution to this problem, you'll have solved with the skills you've learned in this course. Or at least, the skills you've learned in this course may be combined with some of the different toys you might have played with as a child. When you've got the answer, create a variable named client and assign the correct citizen to it. If you do choose to try this challenge, but you find you're unable to answer it at this time, don't worry. Even having made an attempt at a challenge like this has enormous learning benefits. In the next course in this series, we'll learn all about functions, deep diving into why you place parentheses after commands, and all the things you can do with functions, along with the simplest and most elegant way possible to solve a challenge like this one. You can always return here later to catch the mastermind once you have these additional skills. For now,